Okay, everybody, welcome back to Physical Science. This is the second part of a two-part video lesson. And in the last video, we talked about how to get relationships from this table, and we'll review that just a little bit. But what we're going to do today is we're going to learn how to use metric relationships to solve metric conversion problems. Okay, so we did talk about how each of these steps from the base is a multiple of 10. And we did talk about how a person could just move the decimal and get the right answer. Now that would be okay for this, and that is okay for this, but you probably learned that in 6th grade. So what we want to do here for physical science is give you a good introduction to the factor label method. And that is going to take us into understanding and helping you do the math when you get to chemistry in a section called stoichiometry. Okay, so just to kind of review here how we find our relationships, let's say that we need to, and this is where the base is, remember. So let's say that we're talking about meters right now, and we want to find the relationship between meters and milliliters, or millimeters. So kind of what you do is you cross the numbers in the table, and you say 1 millimeter is equal to 0.001 meters, and that's our relationship. Okay, and that makes sense, right? Because there is 1,000 millimeters in 1 meter. Now, if this is a units conversion, then what we really do not want to do is change the number we're trying to convert. So in reality, this always has to equal 1, and that's true with all of your relationships. It always equals 1. With that said, we can switch this upside down, and we can write this 0.001 meters is also equal to 1 millimeter. And that is the same number. They're both equal to 1. Now, why would we want to flip it upside down? Well, remember that this is called factor label method. Okay, so this is factor label method, or I like to call it factor out the label method, because we're going to want to factor out these labels here and leave our number with a label that we're going for at the end of our conversion. Okay, so let's see how this works. We're going to give ourselves a couple problems and see if we can work on them together. Okay, in our first problem, we start out with 700 milliliters, and we're trying to figure out how many liters we have. Okay, so we're going to liters, so we don't know how many liters 700 milliliters are. Now, like I said, you could move the decimal, but I want you to get into the habit of doing it in this way. Now, notice there is a base in this conversion, so this will be a one-step problem. Okay, so our base is right here, liters, and we're going for milliliters right here. So this is the number that we use. Our relationship that describes this is 1 milliliter. Remember, the number here always goes with the base is equal to 0.001 liters. Okay? So if you do the way I suggested, you can draw in your table like this. Now there's one other way to draw the table, and I'll show you that on the bottom of this page too. But what you want to do first is put in your known. So we have 700 milliliters. And we want to cancel out that label, right? So we're going to take this units factor, this label, factor label units, and we're going to plug this in. Now keep in mind, this divisor line here, if something's on top, you have to multiply. If something's on the bottom, you have to divide. Now, the way that we figure out which way we're going to put this in is we have to look at the label. Milliliters. Well, if we put milliliters down here, is that going to factor out the label? Well, yeah, because I'm going to put the top here. Because you look at this milliliter here, if you divide milliliters by milliliters, that cancels it out and equals to 1, right? Just kind of on a side note, 4 divided by 4 equals 1, right? So milliliters divided by milliliters equals 1. And that's kind of the whole story of this situation, is we're factoring out that label. And so we figure out how this conversion goes in according to how we can factor out the label. Now we're left with this label here, which is what we're looking for. So now we can actually do the math. So this is how we're going to do the math here. Okay, we brought up our little calculator. So you're going to want to look right here. Our first number is 700. So you put that in, 700. And then you go to the second label here, and the number that we are working with, now one of the numbers, I got these little dots here I'm going to erase because it looked a little confusing, but whenever we do this, there's going to be one number that's 1. Well, we never have to do any math with that because 1 divided, or anything divided by 1 is the same number, and anything multiplied by 1 is the same number. So it's the other number that we have to do something with in this case. So since this is on top, then we multiply those two numbers. So get our calculator back up here. We already put in 700. We're going to multiply by 0.001, push equals, and there we have our answer. So our actual answer to this problem is 0.7 liters. Okay, and that's to factor out the label method. Let's try another one. Okay, our next problem here is we're trying to figure out how many meters are in 943 centimeters. So we're going to be looking at the base meters here, and we're going to be talking about centimeters. So this is the number that goes with that. This is the number that goes with that. The relationship then that we have is 1 centimeter is equal to 0.01 meters. Okay, so that's our relationship that we get to work with. So now we're going to fill in our little table here, and we're going to try to factor out that label. Okay, putting m up here, knowing that when we get to m, we're going to be good. So you put your number in the top, 943, that you know, centimeters. I'm going to ask you now, how do we put this in? Remember, we have to factor out the label. Well, it looks like we're going to have to put it in upside down, right? Because this label needs to be on the bottom in order to get rid of our centimeter label we have up here, right? So 1 centimeter is equal to 0.01 meters. Okay, so now we're going to go look and see if we can factor out our labels, and we do. We're left with the label that we were looking for. So now it's just down to doing the math. So we take up our calculator here, and we can say, I'm going to clear out our last answer, 943. And then the number, again, I want to say, you know, number 1 we don't do anything with because it doesn't change the number. It's the other number that we always have to do something with. In this case, the number is on top. So what we're going to do is multiply, right? So 943 times 0.01, and we get an answer of 9.43 meters. Okay, there's a couple examples for you. Hopefully that helps out. I'm going to give a couple examples of two-step problems next. Okay, there is a way to do this as a one-step problem too with the factor labeling, but there's also a way to do it with just moving the decimal by counting the steps. Neither of those are what I want you to do though, because like I said, this is practice for something that's going to be more difficult. Now if you want to check your answers with the easier ways, you can go ahead and do that, but in order to get the points on the worksheets, you're going to have to follow this process. And hopefully you really learn how to do it. So the first thing you got to do is figure out your relationships. Okay, so you do not see a base here, but the base unit is meter, right? So we're going to need to find two relationships. One between meter and kilometer, okay? So I would say that 1 kilometer is equal to 1,000 meters. Just like before, you can see here that the base, or the number, goes with the base. Okay, and then the other number is 1. Okay, so the other relationship that we're working for is between meters and centimeters. Okay, so 1 centimeter is equal to 0.01 meters. And again, I just want to point out that the number besides 1 goes with the base. Okay, so now that we have our two relationships over here, we're going to plug them into our factor labeling problem. Okay, so you want to start out with 24 kilometers. Okay. Now this is going to be a two-step problem, so we're going to need to do, two conversion factors. Okay, so you're looking for kilometer. I see kilometer up here, right? And in order to get rid of kilometer on top, we're going to have to get this on bottom. Well, the number follows it. So 1 kilometer is equal to 1,000 meters. Okay. We can see our kilometers are canceling out. Now we have meters, but we're actually going for centimeters. So we're going to have to look at this relationship here. And meters, in this case, happens to be in the correct position already. So you just leave your conversion alone. 0.01 meters is to 1 centimeter. Okay. So you just cancel out those meters. Now look, we're left with the label that we were looking for in the beginning. Now we can go ahead and do the problem. Now this is going to be a two-step calculator problem. There are multiple ways to do this. I'm going to show you the way that works every single time with every calculator, and that's pushing equals after every number entered. Okay, so besides the first, 24, okay, you look to the factor. Our number that we're working with here is on top, so it's a multiplication problem, right? So we got 24 times 1,000. Okay, now this is the part where you have to push equals now, and that'll work with all calculators you use. But you just leave that answer alone up there, now that you have it equals, okay? Then you look to your next math problem. So in other words, you're done with this, okay? Your calculator has the number, the answer that takes you past that. Now here's the non-1 number that we have to deal with, and that is in the bottom. So now you're going to have to divide that. You know, it's just the same mathematical rules. It's just kind of a string of math together. So you divide then divide by 0.01, push equals again, and then you finally have your answer here of 2.4 million, and that is centimeters, okay? So that would be the correct way to do a two-step problem using the factor label method. We're going to give it one more try, and then I'll let you guys, try to complete your homework. Okay, so this problem is taking 43 milligrams and going to hectograms. Okay, so this is also a two-step problem. The base is grams, okay? So the first relationship I want to talk about is between milli and grams. So I'm looking at the number over here. So I have 1 milligram is equal to 0.001 grams. And then the second relationship, I'm going to hectograms. And I know that my hectogram number is over here. So 1 hectogram is equal to 100 grams. So those are the two relationships that we're going to be using. So I can make my chart, and I have 43 milligrams. I'm going to put this relationship in first, and I have to put it upside down so I can factor out the label. So 1 milligram is equal to 0.001 grams. And I can just check now, make sure I'm canceling out my milligrams. I still need to get rid of my gram label, so I'm going to use this factor, and I'll put it in just the way it is. 100 grams is equal to 1 hectogram. And you can see that that gram is canceling out that gram. And now I can just go ahead and do the math, okay? So I'm going to clear my last answer, and I'm going to say that 43 times, since the number's on top, 0.001, and remember to push equals every time, and then you get to your next factor, and it's on the number is on bottom that you're working with, So it's a divided by, and that's going to be 100, and push equals again. And then my number for my final answer is 0.00043, so 0.00043, and the label I'm left with is hectograms. And that is the factor label method that'll go with you into college. Might as well learn it now, make yourself efficient. Thank you very much, have a great day.